Somewhere between Mars and Jupiter drifts one of the strangest objects in the solar system, an asteroid called 16 Psyche. Scientists believe it may be the exposed metallic core of an ancient failed planet, a world whose rocky outer layers were violently stripped away billions of years ago. If that theory is correct, Psyche is more than just an asteroid. It is the naked heart of a planet. And now, humanity is on its way to visit it. In October 2023, NASA launched the NASA Psyche spacecraft aboard a SpaceX Falcon Heavy rocket. Instead of using conventional chemical propulsion, the spacecraft relies on a solar electric ion propulsion system powered by xenon gas. The engines produce only a gentle but continuous thrust, allowing the spacecraft to slowly spiral outward through the solar system with remarkable fuel efficiency. That slow journey is about to receive a dramatic boost. On May 15, 2026, the Psyche spacecraft will skim just 4,500 kilometers above the surface of Mars at a speed of nearly 19,848 kilometers per hour. The maneuver is known as a gravity assist, a technique that uses a planet's gravity like a cosmic slingshot to accelerate and redirect a spacecraft without consuming large amounts of fuel. NASA engineers describe gravity assists as borrowing momentum from a planet. In Psyche's case, Mars will subtly bend the spacecraft's trajectory and increase its velocity, helping it continue toward the asteroid belt more efficiently than ion propulsion alone could achieve. But the Mars flyby is not just about navigation. According to NASA, mission scientists plan to use the encounter as a major rehearsal for the spacecraft's future operations around Psyche itself. The spacecraft's multispectral imager will capture thousands of observations of Mars, helping engineers calibrate instruments before the probe reaches its final destination in 2029. As the spacecraft approaches Mars, the planet will not initially appear as a bright full disk. Because Psyche is approaching from the night side of Mars at a steep viewing angle, the planet first appears as a thin, glowing crescent, almost like a new moon seen from Earth. NASA recently released images showing the faint crescent surrounded by sunlight scattered through Martian dust high in the atmosphere. Mission scientists are especially interested in whether Psyche can detect a faint dusty ring around Mars. Researchers suspect that micrometeorite impacts on the Martian moons Phobos and Deimos constantly eject dust particles into space, potentially forming a barely visible torus around the planet. The geometry of the flyby may allow sunlight to illuminate this dust for Psyche's instruments. The spacecraft will also search for tiny satellites near Mars and study how the planet's weak magnetic environment interacts with charged particles from the Sun. These observations serve as practice runs for future operations around asteroid Psyche, where scientists may search for small moonlets orbiting the asteroid itself. Yet Mars is only a waypoint. The true destination remains one of the greatest mysteries in planetary science. Unlike most asteroids, which are composed mainly of rock or carbon-rich material, Psyche appears unusually rich in metals such as iron and nickel. For decades, scientists suspected it might be the exposed core of a primordial protoplanet, essentially the remains of a world that never fully formed. More recent studies suggest the story may be more complicated. Measurements of Psyche's density indicate it may not be a completely solid iron core after all. Instead, it could contain a mixture of metal and silicate rock, perhaps resembling rare meteorites known as mesosidereites. Even so, Psyche remains one of the most metal-rich objects ever explored. That uncertainty is exactly why the mission matters. Earth's core lies roughly 3,000 kilometers beneath our feet, hidden beneath crushing pressure and temperatures approaching 5,000 degrees Celsius. Humans will never drill deep enough to see it directly, but Psyche may offer something almost as valuable: a natural window into the interiors of rocky worlds. By studying Psyche up close, scientists hope to answer some of the biggest questions in planetary science. How do planetary cores form and separate from rocky mantles? How do metallic worlds cool and crystallize? Could Psyche once have generated a magnetic field like Earth's? How violent were the collisions that shaped the early solar system? The answers may help explain not only Psyche itself, but also the hidden interiors of Earth, Mars, Venus, and countless rocky planets beyond our solar system. NASA expects the spacecraft to arrive at Psyche in late July 2029 and begin orbital science operations shortly afterward. Over roughly 21 months, the probe will map the asteroid's surface, measure its gravity and magnetic properties, and study its composition in unprecedented detail. For now, though, all eyes are on Mars. The upcoming flyby is only a brief moment in a 6-year journey across deep space. Yet it marks the point where the mission transforms from a distant ambition into a real approach toward one of the solar system's most mysterious relics. Somewhere ahead, drifting silently between the planets, waits a metallic world that may once have been the core of a lost planet. And for the first time in history, humanity is closing in on its heart.